Ladies and gentlemen, thank you for joining me for my presentation on mine planning as part of the system, which is part of the Mine Planning Colloquium 2017. Let's understand how a general manager would try and explain. I've created a make-believe mine here called MPC SiMINE mine, and we've got an actual profit of 7 million Rand for this month, and the budget was 10 million Rand. And the question is, why have we not performed? And the GM would like to understand why there is a 3 million Rand underperformance. Let's try and understand underperformance and understand what are the levers driving that. So there's your budget of 10 million and your actual is 7 million. So it's red because it's below. If we drill down one level lower, we see, our costs are actually 1 million lower than our budget of 20 million. It was actually 19 million. So that's a good thing. But our revenue was down 4 million Rand because we actually only achieved 26 million Rand. So you can actually see that our revenue was actually even worse than what we thought because it was offset by some reduction in profit. If we drill down even further, we can see that our exchange rate achieved was actually better, 15 versus 14. Our price per kilogram was also better. So in fact, our production is even lower than what we believed it was. We budgeted 7,995 kilograms. We actually only achieved 6,691. So it's driven by production. And that production is driven by what is that mining value chain actually achieve. So you've got drilling, blasting, loading, hauling, crushing, and processing. And what has that system actually delivered? Well, that system actually delivered that production. And the question is, well, what activity in that system is actually not performing, and why did that system not actually achieve its budgeted 7,995 kilograms? So let's understand if we can actually understand that non-performance in more detail. So there you've got your product. We are only achieved 6,691 kilograms. Let's drill down further. There is a yield. In fact, our yield was better than what we thought. So again, it's all production driven. And we, in fact, are down on tons significantly. So the question is, what in that value chain actually caused that non-performance? And was it something to do with the ore body and the mine plan? So you're looking at that whole system now, we're down on production. So let's understand why. If you had found out which was the constraining activity, here's an example then of the individual just looking at the hauling activity alone. So let's assume and there's a whole analysis to find out what is the constraining activity. And I will discuss that more in another presentation. But let's assume it was hauling. The overall measure of hauling productivity is really what production was produced in a period of time. So let's say it's the production in a month. And let's drill down. That's made up of a throughput rate, which is your tons per hour that equipment could actually produce, versus the direct operating hours. How many hours that it actually was operating. Then if you have a look at your throughput rate, it's based on your average load, which is your tons per load, which is made up of your truck capacity and your bucket fill factor, often called fill factor. The truck cycle time, which is your minutes per cycle, impacts your throughput rate, and your truck cycle is made up of all the components of the cycle time. Time queuing, time loading, time traveling. It could be the time traveling full and empty. If we now move to the direct operating hours side of the equation, we'll see that that's made up of your available hours, which is your scheduled time, which is how many hours that operation is actually operating for. And then your maintenance hours, which is the planned maintenance and unplanned maintenance downtime. And then your unutilized hours, which really needs to only be broken down into 4 areas for us to do proper understanding of the interconnected nature of those activities, which would be external delays. External delay being, for example, a rain delay or a fall of ground or labor or electricity outage. Those are all external from the actual system. Internal delays would be something within the activity itself. So, for example, a operator not available would be an internal delay. Then starving delays is when a piece of equipment is starved of material. So hauling is being starved of material from loading. That's a starving delay. And a choking delay would be that the truck can't tip into the crusher, and that would be a choking delay, so it's being choked. Let's understand the root cause of that reduced production. So now we've got all those silos of activities there, drilling, blasting, loading, hauling. We've got individual variability in each of these. And you need to understand the overall value stream performance of those interconnected activities. Where is the constraining activity? What's the plan, compliance? So there's a lot of different things that you could focus on. And this is the challenge in mining, is that what is actually causing the non-performance of each of those different activities have a whole lot of different variables and variability. And even more importantly, it might have nothing to do with the actual execution of the mine plan. What says the mine plan is actually correct? So here we are, performance managing actual production and shouting at the production guys when in fact there's no way of validating whether the mine plan was actually an achievable mine plan. And if we even go back further, did we actually have a representative ore body in our model with the grades and material characteristics in geology? So if you look at that overall system, it pays respect to the ore body, the mine plan, and the execution, and we need to performance manage that whole system, which often is not done adequately in the mine at the moment. Importantly, mine planning is part of this overall system, because if you have a look at the way that a normal planning is done, you've got your resource model. That's normally done on an annual basis. That's handed over or integrated into mine design and scheduling. And the mine design and scheduling is all done based on latest phase positions, the latest resource model, with ideally some realistic scheduling scenarios. And that is then handed over to probably the HR department. Often it's not even an input into the resource planning, but you need a realistic resource budget, which is the manpower required to actually deliver, plus all the equipment hours and all of that. So we need realistic efficiency assumptions, equipment availability, and then that is handed over to the finance department, where they generate the cost budget based on ideally a realistic bill of materials, wastage rates, unit costs. And unfortunately, there's often no feedback loops between any of that. That can take anything up to 6 months to do. And that's just one budget. And is it even realistic? Mine planning is actually the most critical part of the system, because without a proper mine plan, or what's called operational planning, which takes into account the resource model, mine design, production schedule, resource plan, and the finance budget, we actually can't effectively execute. And then we end up trying to optimize and make decisions while we're executing, without having an actual detailed operational or accurate operational plan. So if we had a proper integrated operational plan, that is the most important first step to effective execution. So that would generate the design. It will give you a task schedule of what every single task to execute on that mine effectively, right down to which equipment should be working in which area, all the resources required, which is an important thing, because if the operational plan is done correctly and we've now gone and done the proper task schedule and the resources required to execute on that task schedule, we have the right resources in execution and then the budget to support that. And then you can execute. And that execution then is about executing on the task schedule with the resources that you've actually planned. And if we get that right, then we can execute with the right efficiencies and performance of the mine value chain. So integrated operational planning is a critical first step to the overall mining system performance. And importantly, it should have a feedback loop as well. The overall mining system is not just about the interconnected activities of the value chain. Integrated planning is a critical, well, probably the most critical first step of that system. As we said, it generated the executable task schedule, the required resources, and then the overall above that, the devices and instruments, the MOM and MES control layers, all the data and the organizational design, which incorporates levels of work, measures, work routines, which feeds into your actual insights and actionable decisions, is critical. And this is the overall mining system.